Hey guys, it's Miss Klein. I'm going to be teaching you how to solve area equations. So what we're going to be doing today is we are going to be combining what we've been learning in geometry with what we've been learning in our previous unit working with equations. So today, what I'm going to need you to do is get out a sheet of paper and you're going to turn in a picture of your notes if you are a distance learner today. And you're going to, like I said, take a picture of notes, attach them, but you will need to have this heading on the top, so solving area equations. Now, throughout the video, if you need more time, if I'm going too fast, you can always pause the video, finish writing whatever it is you're writing, and then start the video again. Okay, so if you ever need more time, do that. So we're going to continue working on 6G1. That's the standard that we worked on Thursday and Friday, finding the area of triangles, quadrilaterals, and polygons by composing and decomposing into other shapes, and to solve real world problems. So we're working on that real world problem part of that standard today. And we're going to continue working on the standard the rest of the week. So our essential question today is, how do you use equations to solve problems about areas, rectangles, trapezoids, and triangles? So again, we're combining algebra and geometry for this lesson. So just to review, what are the formulas to find the area of the following shapes? So remember, a rectangle and a square share the same formula. You've got your triangle formula, your parallelogram formula, your trapezoid formula, and your rhombus formula. What I'm going to have you do is I need you, instead of me writing these down and then moving on and you not being able to see them, I need you to get out your formula sheet. So we started this formula sheet Thursday, and then we continued it Friday by finishing up with trapezoids and triangles. I want you to get that out in front of you so that you can reference those formulas when we need them. Okay, so the first thing you're going to write on your notes is the steps to solve area equations. So you're going to write these 5 steps on your notes. The first thing you're going to do is write the name of the shape. You're going to focus in on the name of the shape. Thank you. When you are working on these, because that's going to help you do number 2. Write the formula. So you've got to know what shape you're dealing with in order to know which formula you need to pick from your sheet. Next, you're going to draw the shape and label what you know. A lot of kids want to skip this step, but this is a really helpful step. Draw the shape and label what you know, because that sort of turns it into like a worksheet that we've solved or that we are working on solving problems on Thursday and Friday. You've got a visual there of what you're working with, and it helps you clearly identify what each piece of the shape is and where to correctly put it. Next, you're going to fill in what you know in the formula. So that's what we did Thursday and Friday. We're going to plug in what we know. This time today, though, you're going to know the area every time. So it's going to be a little bit different today because you're going to know the area, and you're going to have to plug in the area number instead of leaving the area blank and just writing A. And then next, you're going to solve like an equation. So we're going to apply our algebra skills. All right, so next, what we're going to do, you've got your orange sheet out in front of you. You've got your notes. What I want you to do now is write example 1. Now, you do not have to copy this example down, but anything that I write on the board, I want you to write on there with me. So it says, Renee is sewing a quilt whose pattern contains right triangles. Each quilt piece has a height of 6 inches and an area of 24 inches or squared inches. How long is the base of each quilt piece? So notice they're not talking about the entire quilt here. They're just talking about these little pieces that you can see in the picture. So it would be like this piece or this piece, okay? So what we're going to do is we are going to focus in on the shape that we're working with here. So it says contains right triangles. Notice those are right triangles. Right triangles, if you'll draw the shape with me, have a 90-degree angle there. So it's like the corner of a desk or a door or the corner of a room, a 90-degree angle. Each quilt piece has a height of 6 inches. The height is how tall something is. So we're going to write that this quilt piece is 6 inches tall and has an area of 24 squared inches. Now here we go. This is different from what we did Friday when we were working with triangles because we know the area this time. So it says, how long is the base of each quilt? So I like to write the area inside the shape and circle it. And then I want to know my unknown. I'm going to use a variable. Going back to algebra, I'm going to use a variable and represent my unknown b. Okay, so what I need to do next, if we go back to the steps, it says name, write the name of the shape. Draw, I sort of skipped a step, draw the shape and label what you know, and then write the formula. This is a triangle. So we're going to write triangle, draw our triangle, label what we know, and then I always like to just go ahead and write my area formula for a triangle, which is 1/2 base times height. Okay. So now if we go to our steps, we've done all 3 of these. Next, I need to fill in what I know to the formula. So I am going to plug in what I know. Area, do I know the area? Yes, remember I put it inside there. So I'm going to replace A with 24, bring down my 1/2. I don't know what the base is, so I'm going to leave that as a variable. And then my height is, and you could even, when you label this on your shape, say H is 6. That way you know to plug in 6 for H. Now, let's talk about what's happening here on this end of the equation. Because basically, guys, you need to understand formulas for area, they're basically equations, okay? So you are going to, what's happening here, they're all being multiplied. If you want to put dots there like we've talked about to show that they're being multiplied, that's fine. So next what we're going to do is we've got to get B by itself. We've got to clean it up. So going back to solving an equation, my goal to solve the equation to figure out what my mystery number is to get that variable, in this case B, by itself. Well, what's attached to it? 1/2 and 6. I'm going to simplify that. So I'm going to circle 1/2. Do that with me. 1/2 times 6. So in your calculator, you could do 0.5 times 6, or just remember that 1/2 times 6 is like saying half of 6. And what's half of 6? 3. Now I still have B there, so I'm going to bring B down. I'm going to bring down my equal sign and 24. All right, so now this looks like a one-step equation that we've been solving in our algebra unit. So this really was the new part where we're trying to get B by itself, but there's 2 things attached. I'm going to combine those 2 things and complete that math. Bring that single number down with B, and now I only have 1 thing attached to B. So now my goal is to get B by itself. They're multiplying by 3. So I am going to do the opposite, the inverse, and I'm going to divide by 3. What I do to one side, I must do to the other to keep my equation balanced. So if I have 3 B's and I divide them by 3, that cancels each other out and gives me 1 B, which I show with just 1 B. And 24 divided by 3 is 8. So B is 8. So going back, we need to go back into the problem and figure out what is 8 representing. The question says, how long is the base of each quilt piece? The base is 8. Now, what are we measuring things in here? If you go back and look after the number, we're using inches. So 8 inches. So my final answer, since this is a word problem, we need to include a word. The base would be, I'm going to write base is 8 inches. And that would be my answer. Okay? So again, if you need to pause this to finish writing or rewind it to review a piece of what I'm teaching, you may do so. We're going to go on to example 2. Go ahead and write example 2 here. It says the Hudson High School wrestling team just won the state tournament and has been awarded a triangular pennant to hang on the wall in the school gymnasium. There's a picture of what that might, some of y'all might not know what that is. There's a picture there to the right. The base of the pennant is 1.5 feet long. It has an area of 2,500 square feet. What is the height of the pennant? Well, first of all, I have to, if you don't know what pennant is, there's a picture there, but there's a word here that tells me what I need to know. Triangular. So I am going to draw the pennant. I know I'm working with a triangle. Let's write triangle underneath example 2. I know the pennant is shaped like this, but I want to fix that. I want my triangle to be sitting on the base. So I'm going to draw my triangle. So again, we're going to write what shape it is. We're going to draw a picture and label what we know. It says the base is 1.5 feet long. I could even put B equals there just to clarify that. And then it says it has an area of 2.25 or 2.25. I'm going to circle that because that's my area. Now it says, what is the height? Now the height of this triangle is going to go down the middle from the tallest point to the base. I'm going to put H right there. That's what I'm looking for, the height. So what I need to do first is write my area formula for a triangle. A equals 1/2 base times height. If you don't have these memorized, that's why we made that cheat sheet, the area formula sheet for you, so that you can look at it and reference to it and write the correct area formula down. Remember, we are going to have an area formula quiz Thursday, March 18th. So you need to be studying and memorizing those, memorizing the shapes, what they look like, their names, and then the area formulas that match. Okay, so we've got, let's see, we've done 1, 2, 3 again. Now we're going to fill in what we know and then solve it like an equation. So we know the area is 2.25, 2.25 equals 1/2 times, if you want to put that symbol there to help you, your dot, you can. The base this time I know is 1 5/10 or 1.5 times the height. That's what they're asking. That's what I don't know. So I'm going to make that my variable. Okay. So what we're going to do is we are going to, now that we've plugged everything in, we're going to do number 5, solve like an equation. So my goal is to get H by itself. What's attached to H? 1/2 times 1.5. So what I'm going to do is I'm going to clean, now this is the new thing again. We've not really worked on this where we've got 2 things attached to the variable. We're going to clean this up. We're going to combine these 2. We're going to do 1/2 times 1 5/10. Now remember, you can use a calculator here as long as you're showing all of your formula lines. So you could do 1/2 times 1 5/10, which is the same thing as 1/2 as a decimal, is 0.5 times 1.5. Okay, so when I do that multiplication in your calculator, I'm going to give you a minute to do that. You're going to get 0.75. Now, the 2 things I've circled, I've simplified. I'm going to bring down my H, bring down my equal sign, bring down my 2.25. Okay? And now my goal is to get H by itself. So what's attached to H? This looks familiar. It's a one-step equation now. They are multiplying by 0.75, so I'm going to divide, do the opposite or the inverse by 0.75. Remember, it's an equation. They're equal on both sides. It's like that scale, that balancing scale. If you do something to one side, you need to do it to the other. So I'm going to divide by 0.75. Over here on this side, this cancels out and gives me H. And then in your calculator, I want you to do 2.25 divided by 0.75. And you're going to get 3. So we need to connect this back into the context of the problem. What's my final answer? The question says, what is the height of the pennant? So I'm going to say for my final answer, the height is 3, and our measurements are feet. So the height is 3 feet. So that pennant they're hanging in the gym, the height of it's going to be 3 feet. Okay, again, if you need more time, pause the video. We're going to move on to example 3. Example 3, you're going to write example 3 on your paper. It says the cross section of a water bin is shaped like a trapezoid. Now, that might be hard for you to understand what that is. That would be this right here, okay? And that's a trapezoid. The bases of the trapezoid are 18 feet and 8 feet long. It has an area, again, we know the area this time, of 52 square feet. What is the height of the cross section? So what we need to do is look at for our shape. We know that we're working with a trapezoid. So underneath where you wrote example 3, I want you to write trapezoid. And then we're going to draw one. Okay. Now let's label what we know. It says the bases are 18 feet and 8 feet long. Well, 18 feet needs to be the longer base. Now the bases, again, we talked about this Friday. The bases are the parallel sides. Okay, they're not going to be the same length, but they're parallel from with each other. So 18 feet is going to be my longer one, 18 feet. And then my shorter one is going to be 8 feet. And then I know it has an area of 52 square feet. So I'm going to put 52 in the middle. So they're asking this time, what is the height? So what we need to do first is we need to write our area formula for a trapezoid. Again, that's where you should be using your cheat sheet. You're going to find a trapezoid and write the formula that we recorded on that sheet. Okay, I'm going to plug in what I know. I know the area is 52. Bring down half because that's going to change. I'm going to indicate that's multiplication. I don't know the height. We need to add that there. That's what I don't know. So I'm going to leave H there. But I know my bases. Here's base 1, base 2. My bases are 8 and 18. So again, I'm going to solve this like an equation. My goal is to get H by itself. Well, you notice what's attached to H. There's a lot attached. So we're going to start thinking order of operations. What would I do first to clean this up? I'm going to do the parentheses. I'm going to add 8 and 18, which make 26. I'm going to bring down my H, indicate that they're being multiplied, my 1/2, and my 52. Now this turns into a problem like the past 2 examples that we did, where we have 2 things attached to H that they're all being multiplied. So I'm going to multiply 1/2 times 26, or remember, I could say 1/2 of 26, or if you enter it in your calculator, you could do 0.5 times 26. I like using this. 1/2 of 26 means you're multiplying. So I can say 1/2 of 26, which is 13. Bring down my H, bring down my equal sign, bring down my 52. Okay, now this is a one-step equation like what we worked on when we were in algebra. My goal is to get H by itself. They're multiplying it by 13, so I'm going to divide by 13. What I do to one side, I must do to the other. This cancels out and gives me 4. So what I need to do is plug my answer, since this is a word problem, back into the context of the problem. It says, what is the height of the cross section? So basically this right here, what's the height? We just did those calculations. And so we can write that the height is 4 feet. And there's my answer. Let's do another trapezoid example. Again, if you need more time, you can pause it. I want you to write example 4 on your notes. And it says a garden is in the shape of a trapezoid. So we're working with another trapezoid. I could go ahead and write that down. I'm going to write the name of the shape. And it has an area of 44 and 4/10 square meters. One base is 4 and 3/10 meters long, and the other base is 10 and 5/10 meters long. The height of the trapezoid is the width of the garden. How wide is the garden? So this time they're telling me they're wanting to know how wide the garden is, but up here they're telling me the height of the trapezoid is the width. So here, height and width are the same thing. So I know if they're asking how wide it is, means they're also wanting to know the height of it, okay? So we're going to draw a trapezoid. And we know the area is 44.4. I'm going to put that in the middle and circle it. It says one base is 4 and 3/10, 4.3, that's the shorter one. Meters, the abbreviation for meters is lowercase m. I'm going to put that up with the shorter one, and 10.5 meters, or 10 and 5/10 meters, is going to be the longer base. We don't know the height. That's what we want to know. They're calling it the width, but what they're doing is they're looking at this garden from like an aerial view, straight down at it. It looks like the width when it's sitting down, but when we're looking straight down at it, they're actually wanting to know that height. Okay, so we're going to write the area formula for a trapezoid. Area equals 1/2 h, parentheses, b1 plus b2. And then I'm going to plug in what I know. I know the area this time is 44 and 4/10 equals 1/2 times h, which is what I don't know, and then times parentheses, base 1, which is 4.3, plus base 2, which is 10.5. We're going to plug in everything we know. Okay, my goal when I'm solving an equation is to get h by itself. I need to use order of operations and clean this up a little bit. So I'm going to solve what's in the parentheses. I've got 4.3 plus 10.3 is going to be 14 and 8/10. These parentheses indicate I'm multiplying, so I'm going to put a dot, bring down my h. I'm multiplying the half, bring down my equal sign, and I have 44.4 equals, and I'm bringing that down. Okay. Now this is like the triangle one that I had. I'm trying to get h by itself, example 1 and 2. So I'm going to combine these two. I'm doing half times 14.8, which you could do 0.5 times 14.8, or you can say half of 14.8. Okay, well in my head, half of 14 is 7. Half of 8, so point is 4. So half of 14 and 8/10 is 7 and 4/10. Bring down my h because it's still there, and my 44.4. Again, my goal is to get h by itself. What's attached to h? They're multiplying by 7.4. I'm going to divide by 7.4. What I do to one side, I must do to the other. I'm going to run out of room here. Had to put my decimal up there. So in my calculator, I'm going to have to put my answer over here. 44.4 divided by 7.4, and that's going to give me 6. So I know the height is 6. And what is our measurement here? Meters. And they're technically asking for the width, but we know height and width is the same thing. So we're going to say the width is 6 meters. Okay. Again, if you need more time writing that answer, pause the video. I'm going to move on to example 5. We've got 2 more. Now we're going to work on a multi-step problem. So John and Mary, write example 5 on your paper. John and Mary are using rolls of fabric to make a rectangular stage curtain for their class play. The rectangular piece of fabric on each roll measures, so I'm going to visualize if I unroll that entire piece of fabric, it's going to look like a rectangle, right? If I take that roll and just roll it all out. The rectangular piece of fabric measures 2 and 5/10 feet by 15 feet. If the area of the curtain is 200 square feet. What is the least number of rolls they need? So again, this is a multi-step problem. We're going to have 2 steps. First of all, we're going to write down what shape we're working with. We're working with a rectangle. So I'm going to draw my rectangle. I know when I roll it out, it's going to be 15 feet long and 2.5 feet tall. Okay. So what I'm going to do is I'm going to write my area formula for a rectangle, length times width. And I am going to find the area of that roll of fabric. This time they're not telling me what the area of the roll is. They're telling me what the area of the curtain is. So this is one roll right here. I don't know the area. I need to figure out what the area is. So I'm going to plug in my 15 times 2.5. Okay, and then I'm going to multiply that. So when I multiply 15 and 2.5, I get 37.5. And that's the area of one roll. One roll is going to cover 37 and 5/10 feet of the curtain. But I need my curtain to be 200 square feet. So I need to see how many of these I can fit in 200. So I'm going to take my 200 square feet and I'm going to divide it by 37.5. Go ahead and do that in your calculator. And what I get is 5 3/10. Now, if I go to the store and I try to buy 5 3/10 of a roll, they might let me. They might just cut the 3/10 off, give me 5 total rolls and cut the 3/5 off. 3/10 off. But what about if they won't let me do partial rolls? I would need this fraction of a roll. So what I would have to do is I would have to say, oh, okay, I'm going to need 6 rolls and then just have some left over. So I would need 6 rolls of fabric to make that entire stage curtain, if that's what each roll has in it. Again, if you need more time, pause. We're going to go to example 6. So example 6, a parallelogram shaped field in a park needs sod. The parallelogram has a base of 21 5/10 meters and a height of 18 meters. The sod is sold in pallets of 50 square meters. How many pallets of sod are needed to fill the field? Well, let's focus on this field again. First of all, we're going to write our shape. We're working with a parallelogram. Draw a parallelogram the best you can. It's like a tilted rectangle. Sort of looks like the state of Tennessee. We talked about that in class. Okay, so we know the parallelogram has a base, the bottom, of 21 5/10. And the height, remember the parallelogram, this right here is not the height that's tilted. The height is going to be going directly from the corner to the base. The height is 18 meters. We know the sod is sold in pallets of 50 square meters. Okay. How many pallets of sod are needed to fill the field? Well, let's figure out what the area of this field is. So the area of a parallelogram equals base times height. We're going to write the formula. Again, I get that from a formula cheat sheet. I do not know the area of the field. This is not the area. This is just what the sod sold in, how they sell it at the store. So I'm going to bring down A equals base 21.5 times 18. Okay, so I'm going to do 21.5 times 18, and I'm going to get 387. So area is going to be 387, let's see, square meters. Okay, that's how much I need, but it says the sod is sold in pallets of 50 square meters. How many pallets do I need? Well, I'm going to take how much I need and divide it, split it into 50. So if I pull 150 out from that 387, that's one pallet. Pull another 50 out, that's another pallet. So what I'm going to do is I'm going to do that division, and I get 7 7400ths. Well, what about if they won't let me buy partial pallets? They're not going to let me buy 7400ths of a pallet. So what I'm going to do is I'm going to say, okay, I need 8 pallets, and then I'm just going to have some left over. So I'm going to round up in that instance when they're only letting me buy so much. So that's it for our notes today. What I want you all to do now is take a picture of your notes and attach it to your work. And then you are going to complete the missing measurement problems. There's 6 of them. The worksheet that is attached to your assignment today. You guys need to follow all of these steps. You're going to write the name of the shape, write the formula, draw the shape, label what you know, plug in what you know, and then solve like an equation. Use our notes today as an example of what your work should look like and what steps to take. As always, if you have any questions, contact your teacher. We'll make sure we find time to work with you on this. But make sure you need to attach a picture of your work for today's assignment. I hope you all have a great day, and we'll see you soon.